I'm building a project that requires an H-bridge, and I do not want a conflict of the inputs. These will be the inputs to the H-bridge, and I do not want them to come on at the same time. As you can see here, this is the ground, and it goes both ways. The current flows from the ground up into the H-bridge. As you can see, I put EI, that's electrons. Colleges teach you to go current flow the other way, which to me is too confusing. But current flows from negative to positive with the electrons when this is turned on. So when this is at a ground potential on the gate, it turns it off. So this one turns it off, and this one turns this one off. So all I need is a positive on the input terminals to turn it on. When the gate comes on, these diodes are fed from the other side. So let's say this one's on. Current is flowing up through here. It will also go across to the other side through the diode and put a negative potential on the grid and shut it off. And that's what I want to do, is I want this one to shut this one off and this one here to shut that one off. That way neither one can be on at the same time. And I like to reinforce this. I've got electron current with the I symbol. This is the flow of electrons. Colleges teach the flow of holes, which is the positive. And holes do not flow through a vacuum, so electrons do, but not holes. So they have a lot to convince me that the direction is the other way. So this is the MOSFET configuration. Oh, and I'm going to be using, I can't write it here, a 2N7000. That's what both of these will be. So here's the circuit with the two MOSFETs, the diodes for shutting each other off, and the biasing resistors. This this is a positive lead going to 5 volts. These are the two inputs. So if I put a positive on this FET, you can see the green light, it came on and it switched the relays. This is relay 1 and relay 3. Now current flows from the FETs, negative current flows, the electron current flows from that into the relays to turn them on. So it takes a 0 to turn on the relays. And I'm saying a 1 in my circuit turns it on, which is good because then I can have the microcontroller just produce a 1 and it'll turn it on. And the same thing with the other side. See the blue light's on and it turns on 2 and 4. So the protection that I'm putting on this is if I short these together, nothing happens. It doesn't switch or short out the H bridge. Same thing on this side, and I short it together. Nothing happens. So what if we try, and you can see there is an off condition. So there's nothing when there's no potential on this at all because the two pull down resistors pull down the FETs and shut them off. So if I put these two inputs together, that's my touch light going off. So if I twist these inputs together, so that's like one wire. So if I touch this, you see the green one came on. The blue one came on. Whichever one comes on first will shut the other one off. Now, whenever you touch a wire with anything, you get multiple bounces. So that's why you've seen it switch between blue or green, and it was like oscillating. It's not going to do that with a microcontroller. So and you can see the lights over there that sometimes one side will be on, sometimes the other. So this is the dangerous condition, just having both inputs getting turned on at the same time. But this will protect it from switching and causing a complete short in the relays. And of course, the code in the microcontroller is going to keep everything straight. But there could be that one time there's a mistake, and we don't want that to happen. So one will be on, or the other will be on. These are pretty cheap, and for anybody that wants to try and use one of these, you can see I've connected a whole bunch of wires to it. So let me disconnect all these. So this one's ground, and this one is plus. So now I'm just going to take and show you let's connect this to pin number 1, or input number 1. There you go, input number 1. And so with this other end of the black wire, if I touch it to the plus side, nothing happens. If I touch it to the negative side, it turns it on. So this requires negative logic to operate. So if you ever buy one of these, which are fairly cheap, they're pretty cheap, and just remember it takes negative logic. So a ground is on and a plus is off. And this project is to build a chlorine generator, and I hope to have more videos out showing the progress and more circuit board stuff. So thanks for watching, and come back and see some more.